Welcome. I'm a student, Iyad Mohamed, and my teammate, Omar Mohamed. Our full name and ID numbers can be found in the description. We'll start with example 2.21, the similarity between ordinal attributes. Ordinal attributes, as we know, are attributes in which order matters in them, like the grades we have here. So to solve this problem and get the similarity, first thing we need to do is change these attributes into numbers. So excellent, change it to 3, good to 2, and fair to 1. Then we are going to normalize them. 3 is going to be 1 and 1 is going to be 0. 2 is going to be the middle number between them, 0.5. Then we are going to apply the Euclidean distance on these numbers. Here, for example, we have x1, which is excellent, and x2, which is fair. So the similarity between x1 and x2 will be root x1 minus x2 all squared, which will be 1 minus 0 squared, and the answer will be 1, which we have here. Then we will apply this rule to each point, 2 points we have. Here are the x1, x2, x3, and x4, x1, x2, x3, and x4, and we will apply the rule on each 2 pairs here, and that's it. And also, to find the similarity, all we have to do is subtract the dissimilarity from 1, and then you will have the similarity, and that's it. Now, with example 2.22, the similarity between attributes of mixed type. First thing we need to do is get the dissimilarity matrix of each type or of each attribute. So the nominal attribute dissimilarity matrix, we'll get it by this formula, and the ordinal we'll get it by this formula, as we have done in the previous example. And for the numeric attribute, we will do it by this formula, which is the similarity of 2 pairs of objects is the xi minus xj over max of ij and minimum of ij. So what does that mean? Xi and xj are the 2 numbers here in your table. For example, for 1 45 and for 2 22, and divided, of course it's absolute value, and divided by the maximum number, which is 64, and the minimum number in the table is which is 22. And this is how you get each element in the dissimilarity matrix of numeric attribute. After getting all the similarity matrices, then you need to normalize all the 3 into 1. And how are you going to do that? By using this formula. So what you need to do here is, for each of these 3 matrices, you're going to get for each element, you're going to get each element in each matrix. For example, here 1 and 1 and 0.55. You're going to sum it and multiply it by the number of the column and divide it by the sum of number of columns. For example, the similarity matrix of the similarity of 3 and 1 will be equal to 3 and 1, which is 1, 2, and 3 here, 1, 2, and 3 here, and 1, 2, and 3 here, 1, 0.5, and 0.45. So to be 1 plus 0.5 plus 0.45 times 1, which is the number of column for each one of them, over the sum of 1, 1, and 1, which is 3, and apply it to each element in the dissimilarity matrices you got. By this way, you will get your final matrix. This is the dissimilarity matrix of the 3 attributes of mixed types. So as you can see here, the least similar ones are 1 and 2, and the most similar pair of objects are 1 and 4. So thank you, and as I said before, the full names and ID numbers can be found in the description. Thank you.